All right, so 4.2 is called graphs of rational functions. Like I said, it's a continuation of 4.1. On 4.1, we were doing our vertical asymptotes, our horizontal asymptotes, our zeros, our holes, right? Now, and y-intercepts. Now we're going to put it all together in graph. So this is my advice for order. Simplify your expression to check for holes first. So look to see if you can factor it. Remember, if something cancels, that means there's a hole at that x. Then find your asymptotes. So remember from here, our vertical asymptotes are setting the denominator equal to 0. And our horizontal asymptotes, we look at the highest degree in the top and the highest degree in the bottom. N, highest degree, numerator, M, highest degree, denominator. And then we compare them. If n is less than m, then your horizontal asymptote is y equals 0. If n equals m, then your horizontal asymptote is at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. And if n is greater than m, there is no horizontal asymptote. But if n is 1 more than m, there is a slant. So just know slants exist. The good news is that you're not going to get tested on them. We'll save that for pre-calc. You'll get that next year. Okay? But just know that they do exist.
So we're not going to get in with one more?
I mean, you could know that it exists, but you may not have to graph it. Yeah. Then we find the zeros by setting the numerator equal to 0. Then we find the y-intercept, and there really should just be 1, by plugging in 0 for x. And then you do the graphs. So sometimes if there's enough information to go off of what you just have there with the intercepts on both the x-axis and the y-axis, you can graph based on that. Sometimes you're going to have to plug, actually more than often than not, you're going to have to plug in some extra points to see what the graph looks like in between your asymptotes. Questions so far? All right, so we're going to put it all together, starting with this one. So first thing I want to do is look at my function and see if I can simplify it. Can I factor top or bottom? No. So that means there's no holes, right? Then I want to look at my I order for me vertical asymptotes, which means that the denominator equal to 0, and I get x equals 2. Then I go horizontal asymptotes. What's the highest exponent in the numerator? 0. What's the highest exponent in the denominator? 1. So what happens when numerator is less than denominator? Y equals 0. If it's no, think it could have a slant, which means the top has to be bigger. Then I would look for my zeros. So for the zeros, I set my numerator equal to 0. 3 equals 0 can't be solved, which means there are no zeros / x-intercepts. This is not going to cross my x-axis. Then I look for my y-intercept. Because if there's no way, like if there's no variable in the top, that top can't be 0. So I set my numerator equal to 0 because think about, like in general, if I just gave you a random function and I said find the x-intercepts, how do you do that? 0 for y, right? So if I did that, g of x is 0, right? So 0 equals 3 times x minus 2. So long way around is multiply this by the denominator and this by the denominator. But this is going to cancel always, right? And this is always going to result in 0. It's through the wall. So I don't need to worry about the denominator because it will always cancel out. And that's kind of like a shortcut. When you do the zeros of the x-intercepts with a rational function, with a fraction that's equal to 0, you only have to worry about your numerator. And because 0 can never equal 3, there is none. If that was 3x, it would be 0.
Whenever there's like
If there's no variable,
then 0.
in the numerator, yep.
So if it was like x.
Not 0, it's none. Did you say there's no 0?
No, like x or y. Variable in the numerator.
If there's no variable, then there's there's no 0 or y or x-intercept, yeah.
So if there's like x plus 2 in the numerator, it would be -2?
Correct. Yep. Okay, so then the y-intercept, we take and plug 0 in for x. So I'd get y equals 3 over 0 minus 2, y equals 3 over negative 2. And I get 0, negative 3 over 2, or 0, negative 1.5. Everybody good so far? Good from home? Okay. Now I'm going to plot all that information. So vertical asymptote at x equals 2 is a vertical line through where x equals 2. Horizontal asymptote at y equals 0. Horizontal line through y equals 0. No zeros means it's not crossing through that horizontal asymptote, right? And then a y-intercept at 0 and negative 3/2, or 0 and negative 1.5 is here. Dashed? Yeah, usually the asymptotes are dashed. If you want to draw them in a highlighter or a different color, that's fine too. Tonight's homework is a PDF, so you're going to draw these by hand, so you can kind of choose that, yeah. If you graph this on a graphing utility, you won't see the asymptotes. You'll just see the curves. So just keep that in mind. Okay, so there is a curve in the bottom, right? It's doing something like this. So it gets as close to without touching my asymptotes as possible. So my curve I know looks like that. It always gets as close to without touching those asymptotes. If I'm unsure, I could plug in additional points there. But because I have that 1 point, I'm pretty sure I know where it's going. Now, I also think these are opposite corners. They're not next to each other ever, unless it's an x squared in the top. But I'm going to plug in a point to the right of my vertical asymptote to check. So I'm going to plug in a point like this, which would be 3. So I get 3 over 3 minus 2, which is 3 over 1, which is 3. So I have the coordinate point 3, 3 on my graph, which is here. Which is consistent with the curve being in the opposite corner.
Wait, when you plugged it in, like what numbers did you use?
I just want to plug in, so wherever the vertical asymptote is, I want a plugged in point from the left of it, and I want a plugged in point to the right of it. The good news this time is that we had that 0, we had that intercept, right? So that took care of the left side, but now I need something right side. This vertical asymptote runs through 2. So I plugged in 3, but you could have plugged in 4, you could have plugged in 5, you could have plugged in anything from the right side.
What
Say-
did you plug it into?
Oh, the original. 3 over x minus 2.
Oh, okay.
Yep.
Do you always, like when we're graphing, do we always need to have 2?
You always, well, it depends on how many vertical asymptotes you have. You always need to have a point from each range. If there were zeros on one side, I don't need them. I could get lucky and maybe have zeros on both sides, and then I don't need to plug in additional points. But you've got to have at least 1 point in each little range. So wherever that vertical asymptote is, it splits it into groups. You need to have x plugged in for each of those.
Yeah, why wouldn't there be like, for example, like ones that go like not top left and bottom right?
They could, but then this point would have been up here.
Okay, so
We would have known it from the y-intercept.
So it's usually like diagonal.
Yes, if this has an x squared in the numerator, they could both be up or both be down. So that's why we always plug in that point.
Okay.
Yep.
And the number, like the answer that you get is the X or the Y, like how does that?
When you plug in, so when I plug in the 3, that was my X coordinate.
Okay.
What I get as an answer is my Y.
Okay.
Yep. We're going to do a bunch more, don't worry. Audrey, you good? Yeah. So we start with what? Before that. See if we can simplify it. Can you factor this? No, no holes, right? You don't want to miss a hole, because if you miss the hole, you get all the way to the end, you got to go back and redo it, like we had done like on Friday, remember? That's why I said start doing it from the beginning. So now I go asymptotes, right? Vertical asymptote. Set my denominator equal to 0, and I get x equals 0. Horizontal asymptote. What's true about the highest exponent in the top and the highest exponent in the bottom? They are the same. So this is the leading coefficient one, right? What's the leading coefficient in the numerator? 2. What's the leading coefficient in the denominator? 1. So my horizontal asymptote is y equals 2. Let me stop sharing and reshare because there's a lag. Okay, so that's a 0 or a y-intercept, x-intercept at 1/2, 0. And the last thing I do before I go to my graph is my y-intercept. I plug 0 in. And what is -1/0? Undefined, right? Which means there is no y-intercept.
So if it's like 0 over -1, it's also no y.
No, 0 over -1 is 0. So if the 0 is in the top, it's fine. It's 0. If the 0 is in the bottom, it's undefined.
And the test, if we did that, do you want us to put undefined or do
You'd put none. So like if there's a blank for it, it will say put none. Yeah. Okay, so now vertical asymptote at x equals 0. Oh, well, that makes sense that there's no point there, right? Because we just said that whole line is an asymptote, so no points can be there, which is consistent with our our y-intercept not being there. Horizontal asymptote y equals 2. Horizontal line through 2. The only point we have is at 1/2, 0. But because I have that point, I'm pretty sure my curve is going like this. And then it would also be in top left, but I'm going to, of course, check that. So I'm going to plug in a point that is left of my 0. Anything, -1 is fine. So 2 times -1 minus 1 over -1 would be -2 minus 1 over -1, -3 over -1, which is 3. I plugged in -1, I got out of it 3, so that's my coordinate point. -1, 3 is here, and it's consistent with what I was assuming was happening with the curve in the bottom right and the top left.
And so why, so you're checking for the other, or is it always to the left of 0?
It's wherever the vertical asymptote is. So our vertical asymptote last time wasn't on 0, so we picked a point left and right based on that. This time it's at 0, so we picked the point left and right based on that. Always in respect to the vertical asymptote. Questions on that one? Yeah.
So how do you know where to put the curve on?
You want to plot your point, right? And then those curves, by nature of the behavior of the asymptotes, will always get as close to as possible those asymptotes without ever touching it.
So like what coordinates? How did you know what coordinates to put?
I just wanted something to the left of my vertical asymptote. So I had something already to the right. I need something left. And the vertical asymptote's at 0, so I just plugged in -1, and I got out of it 3. So that's where that point came from.
Oh, okay, and then you graph, okay.
Yep. And you can plot as many points as you want if you're unsure. I could have plugged in like 1 and seen where it is. Like 1, 1 would have been a point on my graph. You could have done that. You can plug in as many points as you want until you know what it is. Just don't spend so much time on it that you don't finish your test. All right, so start the same place, right? Which is see if we can factor this. Can we factor this time? You can factor the bottom, not the top, but you can factor the bottom. So this, the factors of -2 that sum to -1. Good. Can I simplify? No, but I'm glad I factored anyways because I'm going to have to factor to solve for my vertical asymptotes anyways. Okay, so it serves two purposes. 1, checks for holes. 2, I know I have to set those equal to 0 to get my vertical asymptotes anyways. So vertical asymptotes equals 0, and x equals 2, and x equals -1. This time I have 2 vertical asymptotes. Horizontal asymptotes. What's the relationship between the number in the high section in the top, which is 1, and the bottom, which is 2? Less than. So what happens when it's less than? Y equals 0. Good. Then I go to zeros. So I set my numerator equal to 0, and that's my actual 0, or X-intercept. 0, 0. Which means it's also going to be my Y-intercept. I plugged 0 in. No, I set the numerator equal to 0. Plug 0 in for y, for the x. So y equals 0 over 0 squared minus 0 minus 2. And I get 0 over -2, which is 0. If my x-intercept is 0, 0, my y-intercept is also going to be 0, 0. All right, so now I've got a vertical asymptote at x equals 2. Another one at x equals -1. And a y equals 0 for a horizontal asymptote. So now there's 2 vertical asymptotes, which means my graph is divided into 3 parts. So I need to know what's happening in between all those parts. There are really 2 sort of major options in these kinds of questions. It will either be, like if you have 2 vertical asymptotes and 1 horizontal, you're either going to have 2 curves on the outside that are going in the same direction and a parabola shape in the middle, or the reverse of that, 2 curves pointing down and a parabola shape in the middle going up. This is back. Or you're going to have 1 up, 1 down, and a cubic shape in the middle. Again, the reflection can happen. So it's going to be one of those 4 options when you have 2 vertical asymptotes. You just got to figure out which one. So we got to do a little extra work here because we've got to graph some extra points. The only 0 we have is 0, 0. So now I have 3 areas. I need to plug in a point from the left of the first vertical asymptote, in between to see if this is going to be a parabola or a cubic shape, and to the right of that vertical asymptote. I need to know what's happening in all 3 areas, so I plug in all 3 points. So let's start with the one to the left of the vertical asymptote, all the way on the left. So that vertical asymptote is at -1, which means I'm going to plug in the next one, -2. So I plug in -2 over -2 squared minus a -2 minus 2. And I get -2 over 4 plus 2 minus 2, -2, 6 minus 2, -2 over 4, which is -1/2. So I plugged in -2 and I got -1/2. Yeah, hang on. Oh, sorry, that color's hard to see. So that tells me that graph point is here, and my curve is underneath the horizontal asymptote.
So you go 0, -1/2, or?
I went, no, what I plugged in was -2, so -2, -1/2.
On the test, like if, like for example, just say if you plugged in another point, to like find that out, and say it was like -3, like -half, I guess, and if you didn't like exactly go through that.
It's fine.
take off.
Yeah, no, it's fine.
Okay.
Yeah. As long as you have one precise point from each of those ranges, you're fine. Yeah. If you want to plug in extra just to be sure, that's fine too. But yeah. All right, now I know that it's going to do something in that middle, but I don't know what. So it's kind of up to you if I want to jump to one on the outside, because if I jump to the outside and it's in the opposite corner, it's in that top corner, then I know it's going to take on that cubic shape in the middle. If it's in the bottom corner, I know it's going to be a parabola shape in the middle. Okay, so you can jump around if you want to. I'm just going to go in order from left to right. Okay, but so I'm going to plug in the only other easy one here would be 1. So I plug in 1, and I get 1 over 1 squared minus 1 minus 2, 1 over 1 minus 1 minus 2, 1 over 0 minus 2, which is -1/2. So I have 1 and -1/2. Totally coincidence that they're the same point. That doesn't always happen. But now I know that this is going down to the right, which means this is taking on that cubic shape. So it's going up to the left and down to the right.
If it were a parabola, what would the wavelength look like?
If it were a parabola, the 1 would probably have given you like a +1/2, and so it would have gone up.
Like what if it was like a downward parabola?
It can't be this and down.
Oh.
If it's a parabola, the outsides are pointing in the opposite direction. All 3 of them will not point the same direction if it's a parabola.
I'm confused on your work. Is it the jump?
This is what I just did.
That's your coordinate at the top?
That's when I plugged in 1 and I got -1/2. And then I need something to the right of the furthest right asymptote, which that asymptote is sitting at 2, so I'm going to plug in 3. So 3 over 3 squared minus 3 minus 2 is 3 over 9 minus 3 minus 2, 3 over 6 minus 2, 3/4. I plugged in 3, I got 3/4.
Sorry, I'm still confused. How did 2 points in the cubic function one?
The 0 I got from my 0, or my y-intercept,
Oh, okay.
and then the other one I plugged in. So the regular blue one was from our intercept, and then the dark purplish one was what we plugged in. And then we just did 3 and 3/4. So I know that's above the horizontal asymptote, which means it's the top right corner.
And can you kind of just like estimate that line? Like, do you have to do the thing where you plug in?
You need to have a point from each range.
Right, but I mean for the cubic function, because they need more than one.
Like another one on the left. Just those 2 are enough to know what it looks like in the middle.
Okay.
Yeah. And again, your outer band is confirming it, because if that outer band was down, then I would expect a parabola in the middle. If both outsides are down, I expect a parabola going up in the middle. If both outsides are going up, I expect a parabola pointing down in the middle. And you could get like a multiplicity of 0 in the middle there, and now you know that it bounces, and that's your parabola. So that's another way of like saving time on plugging in points, is if you get a multiplicity of an even amount, you know it bounces, which makes a parabola. All right, now what? Factor. So this time I can factor both the numerator and the denominator. This is the difference of 2 squares, x plus 3x minus 3. Denominator, x minus 3, x plus 1. Now what happens? There's a hole. That hole is wherever we just crossed through. If I set that equal to 0, my hole is at x equals 3. Now remember I kept saying on Friday, like, something looks weird when I was plugging it in. You can't plug it into the original. It's always going to give you 0 that way. You have to plug it into the reduced part. So I'm going to plug it into, now this becomes x plus 3 over x plus 1. So I'm plugging it in there. 3 plus 3 over 3 plus 1, and I get 6 over 4, which is 3 over 2. That's where my hole is. So again, you want to plug it in after you cancel out. Otherwise, you always get 0, and that point is gone.
So then that takes the place of the vertical asymptote?
Correct. So now when I find my vertical asymptote, I set my denominator of the new function equal to 0. Vertical asymptote would be x equals -1. There is still 1, right? It's just that there would have been 2 at the beginning. We just lost 1. Horizontal asymptote, exponents are both the same. So this is my leading coefficient. It'd be 1 over 1, which is 1. X-intercepts, I set my numerator equal to 0. X plus 3 equals 0 means my x-intercept is -3. Or the 0, right? Because those are the same things. And the y-intercept, if I plug 0 in for x, 0 plus 3 over 0 plus 1, I get 3.
So, what did you get for the 0?
I set, so the new, this is what you're working with from here on out. I set that equal to 0. This is, the y-intercept is the same thing as the 0. So it would have been -3.
So the 0s you only use
The numerator. Mm-hmm.
Okay. And then we, like, after you reduce it, like, you don't have to pay attention to the first one at all?
Nope. As long as you got the whole, like the x coordinate from that whole, from the first one, you're done with the first. It's simplified.
And what's that new equation that you would just use?
This
to
one.
solve the vertical asymptote?
This is what happens after you cross this out.
Correct. But like, what would you put, like, that's the whole?
It's a simplified, it's the simplified function.
Okay.
So now let's plot our vertical asymptote at -1, our horizontal asymptote at y equals 1. Our x-intercept is at -3, 0. Our y-intercept is at 0, 3.
Sorry, for the y, or for the horizontal
Oh.
asymptote, do you use that new equation as well?
Yep, always the new equation. Everything's new equation. Okay, what do we think this graph looks like? Do we think both arrows point, both curves go up? No, one's above the x, one's above the horizontal, one's below it, right? Top right corner, bottom left corner. But there's a hole. My hole is at 3 3/2, or 3 1/2. So at 3 1/2, which is 1, 2, 3, 1.5 here, I have to have a hole in my graph.
So you just like draw it.
Yep. And if you had it, like, I kind of overwrote it on top of that line, but if the line went through it, I just erased that line. Yep. Just has to be an open dot. Think about what's happening with your domain here, because I think the homework, it does. It asks for domain, okay? Remember, domain is from left to right. So go back a ways, like the last couple chapters we did domain. From left to right is all those values. So the furthest point left is actually an arrow. It would go from -infinity. And then this graph stops at x equals -1 because there's a vertical asymptote. So my coordinate points stop here, which means my domain goes from there to -1. Then it picks up again at -1 but doesn't include it because so it gets the parentheses. And it would normally go to positive infinity if there wasn't a hole, but it stops again at that hole, which is at +3. Then it starts again at +3 and goes to positive infinity.
How come it started again at -1?
So everywhere there's a hole or a vertical asymptote is where it stops and starts.
But it doesn't include.
But it doesn't include it. These will always have parentheses, no brackets.
Is this gonna give a test?
No, domain is not, but it does ask for it in the homework. Yeah. So I'm going to teach you how to find the slant. I don't think slant's on your test. I'll double check. I'm almost 100% sure. Unless you changed it over the weekend. It's not on your test. But I do want you to know what happens. All right, so I'm going to start exactly the same way, right? Can I factor this? Yes. I can take out an x and I get x minus 1. Does that simplify? No. So there's no hole. Okay, even though we can factor it, it doesn't simplify, so there's no hole. The vertical asymptote comes from setting the denominator equal to 0, so x equals -1. The horizontal asymptote, this time the highest exponent in the top is 2, highest exponent in the bottom is 1. That means it's bigger in the top, so there's no horizontal asymptote. But there is, it's 1 bigger, so there is a slant asymptote. Nope, if it's bigger in the top than the bottom, there's none. If it's smaller in the top than the bottom, it's 0. So the way you find a slant asymptote is to divide the numerator by the denominator. So I'm actually going to do x squared minus x divided by x plus 1. You actually divide the numerator by the denominator. Can I use synthetic division here? Yeah. I would do this, right, which is 1, -1, 0. There's no number at the end. Do the bracket and put -1 on the outside.
If there was a square in the denominator.
We would not be able to use synthetic, and we would just divide long division. Bring this down, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. Now here's what's weird. We completely disregard the remainder. You totally ignore it. And you take your quotient and you set it equal to y, and that's your slant asymptote.
How did you know to use -1?
It's always the opposite of what, that, remember what's up after the x, it's always the opposite.
So the slant would be y equals x minus 2.
Yeah, which is a line, so it should make sense that's a slant.
Do you check for a slant asymptote every time, or is it just if?
Only if the numerator is 1 more than the bottom.
Is that gonna be on the test?
No, I'm almost sure. I'll check in case she changed anything this weekend. I haven't talked to her this weekend, but as of Friday it was not. But I will for sure tell you tomorrow. I know she tweaked a little bit over the weekend, but I'll let you know for sure tomorrow. Okay, so now let's plot all this stuff. Vertical asymptote at y equals -1. There's no horizontal asymptote. My slant asymptote is a line. Y equals x minus 2. So I start at my y-intercept, which is -2. This is the b. And I use slope, which is 1. Up 1 and over 1 or down 1 and over 1. And I draw the line through there. So it's just a regular line, which is why it only works if it's 1 more, because I can't make my slant asymptote a parabola.
How did you graph the slant asymptote again?
It's a line, so y equals x minus 2. Start at your b, which is -2, and then your slope is 1, up 1 over 1.
Would that be dashed as well?
Yep, asymptotes are always dashed. My 0, again, comes from my numerator. This time there's 2 of them. X equals 0 and x equals +1.
I have a question. Is this supposed to go through the other
Yes. There has to be a crisscross. And then it's always opposite corners. So it's either going to be here and here or here and here. It makes like an X.
But how did you get the 0, 0, and 1?
I set this equal to 0. So I had already factored it. I just set them both equal to 0.
Oh, okay.
So here are my 2, 0, 0, and 1, 0. And my y-intercept is 0, 0. So I know it's in this corner. It's going to come down and come back out of here, which means it also has to be in this corner. But to be sure, I just want to stress that to be sure, you plug in a point that is left of your vertical asymptote. So if I plugged in -2, for example, I'd get -6. So -2, 1, 2, 3, 4, 5, 6 would be down there. And then that is where my other curve would pass through. So again, we'll do 6 and 7 tomorrow to start class. We'll talk about your test. The homework tonight is a PDF, okay? You can feel free to plug these into a graphing utility and check your work as you're going. Just realize that I'm looking for all the parts when you're building it. I'm looking for all your asymptotes, your zeros, your y-intercepts, and then any additional points that you need.
Do you, that line at the bottom there?
Yep.
Do you put that, or do you just need the curve?
This one?
No.
Oh, I just drew the arrow.
Oh,
Yeah, no, it's just an arrow.
and also if it said what is your y-intercept, would it also be -2?
No, the y-intercept is 0, 0. If I plug 0, that's this one here. If I plug 0 in, it's 0. All right, you guys can go have a fantastic day. I will see you tomorrow.